Welcome students to today's lesson, and we are still continuing with the derivation of belt equation. Today we want to see how to derive the V-belt equation. So in the V-belt we can see that the point of contact that the belt makes with the pulley is among the sides edges of the triangular form. So then it is very important that we extract the forces that are involved, and we can do a normal force. As we can see in this figure here, we have two normal forces. So these are the points where those particular sides of the V make contact with the pulley. So then, having derived those two normal forces, then we need to create a reaction force that is splitting the two triangles into two, and we'll have the angle that separates them as the alpha. So taking the reaction force as the prime objective here, then we need to resolve the vertical forces. The sum of the vertical forces must add up to 0, and as you can see, we have the vertical force due to R is given by twice the normal reaction, the twice n sine alpha. That is when we resolve the vertical component due to this normal. So then, if we rearrange the equation, we are left with 2 times normal is equal to the resultant force divided by the sine of the angle theta. And you also need to keep in mind that the friction of the pulley is given by twice times the coefficient of the friction times the normal force. So then we need also the horizontal component. Remember, we've just computed the vertical component, and for the horizontal component we need to take into account 2n is equal to r divided by sine alpha, which simplifies to r cosec alpha. So the friction force can therefore be substituted if we know that 2n is the same as r, the cosec of alpha. Then friction force is given by the coefficient of friction times the reaction force r, cosec of the angle alpha. So then this part we are still explaining how to derive it, and it is true that the frictional force is given by the coefficient of the friction times the resultant force times the cosec of the alpha. So V belts, if the frictional force in V belt has increased the ratio of the tension and can be changed, therefore the equation that is responsible for this is that we take tension 1 divided by the exponential of the coefficient of friction times the angle theta, and that should give us tension 2. So the ratio of tension 1 to tension 2 is given by exponential of the coefficient of friction times the angle theta times the cosec of the angle alpha. Student, this marks the end of our today's lesson. Let's meet again in the next class.